I'm sorry, sir. I didn't see this. Again, I need to start my program. Okay. So again, I will start with once again, sir. Sorry for the disturbance. Sir, till now we have discussed the lexical analysis and syntax analysis. So from these two phases, if any one of you are having doubts, you can ask. Majorly from syntax analysis, sir, because from the syntax analysis we can get the 2 to 4 number of marks. Majorly we can get the 4 number of marks. It is the 50% of weightage in gate examination from the total compiler design. So you can ask if any one of you are having any doubts from syntax analysis or lexical analysis also. From lexical analysis or syntax analysis, if any one of you are having any doubts, you can ask, sir. So LR0 parsers, LR1 parsers, or LL1 parser, or SLR1 parser, CLR1 parser, or LALR1 parser. The detection of the grammar and construction of the parse table from anything, operator precedence parser. Okay, sir. If you don't have doubts, I can move to the next concept, that is semantic analysis or semantic analyzer. This is the third phase of the compilation phases. So it takes the input as parse tree. It takes the input as parse tree from syntax analyzer or syntax analysis. So, and it produces output as annotated parse tree. Otherwise, in other case, if it is not produce annotated parse tree, it produce error. So that error may be semantic error. So in the process of construction or creation or producing of the annotated parse tree, it uses grammar. That grammar is called as SDT. SDT means syntax directed translation. Actually, it uses context sensitive grammar. So theoretically, it is okay. But coming to the practical, it is not possible. That's why it uses SDT. So what is SDT? I will explain you, sir. So along with this, it uses linear bounded automata. Here, linear bounded automata is also theoretically it is mentioned, but in the place of linear bounded automata, we use parser. Along with the stack. In the parsers, we use one stack, and one more stack we use here. One for checking of the structure and one for checking for the semantics. One for checking for the structure, another one for checking for semantics. So this is the thing, sir. Semantic analysis is the used for the type checking. For that purpose, it takes the input from the syntax analyzer as a parse tree, and it produces annotated parse tree. So here also we are using parser. So that parser may be top-down parser or bottom-up parser. So here we are using parser, and the before phase also we used a different kind of parsing algorithms for construction of parse tree. Sir, why the separate phase is required here? In the syntax analysis itself, can we do the same thing, the construction of annotated parse tree? Yes, we can do it. But syntax analyzer cannot detect semantic errors. Semantic errors cannot be detected by the syntax analyzer. For that purpose, we are using separate phase or separate subprogram that is called as semantic analysis. Semantic analysis. So in the semantic analysis, we use the grammar that is context sensitive grammar. So the structure of the grammar is alpha derives beta, where alpha comma beta, alpha and beta are the Greek symbols, which are belongs to combination of terminals and non-terminals with positive closure. With positive closure, that means at least one terminal or non-terminal, one non-terminal should be exist as alpha and beta. So that is the structure of the context sensitive grammar. But it is very difficult for the construction or construction of parse, annotated parse tree with the help of context sensitive grammar. For that purpose, in place of context sensitive grammar, we are using attribute grammar. Attribute grammar. Attribute grammar. So with the attribute grammar, we can construct annotated parse tree. In place of context sensitive grammar, in place of context sensitive grammar, we are using attribute grammar. Sir, what is attribute grammar? Attribute grammar is nothing but we add the attribute information or type information or attribute information to the grammar symbols by adding attribute information or type information to the grammar symbols. So that grammar is called as attribute grammar. That grammar is called as attribute grammar. For example, S derives ID equals to E semicolon, E derives E plus E derives ID. This is the context free grammar, sir. This is the context free grammar. This is the context free grammar because the left hand side we are having single non-terminal, and in the right hand side of the productions we are having combination of terminals and non-terminals. Any combination of terminals and non-terminals. Suppose if any grammar is in the format of single non-terminals derives combination of terminals and non-terminals with any combination, we can call it as context-free grammar. By adding attribute information, to this context-free grammar, we can get the attribute grammar. So context-free grammar plus attribute information. By adding attribute information or by associating attribute information, we can call that one as attribute grammar. So here, if we add the type, so we can write it as S dot type equals to ID dot type, derives equals to E dot type, and E dot type derives E dot type plus E dot type. E dot type derives ID dot types. So we can call this one as An attribute grammar. An attribute grammar. Sir, by adding attribute information or type information. Sir, what is attribute? What is attribute? Attribute is nothing but the type information. For example, C is equals to A plus B. Here it is int. Here it is float. Here it is float. So these are called as attributes. These are called as attributes. These are called as attributes. This information, that means the type information, if we add the type information to the grammar symbols, here E is the symbol, ID is the symbol, S is the symbol. By adding the type information or the attribute information to the grammar symbols of context-free grammar, we can get the attribute grammar. In the semantic analysis, we don't use context-sensitive grammar. In the place of context-sensitive grammar, we use attribute grammar. Attribute grammar is nothing but context-free grammar along with attribute information. Context-free grammar along with attribute information is nothing but attribute grammar, sir. Is nothing but attribute grammar. So, and next one is here in the syntax. In the syntax semantic analysis, along with the context-free grammar, if we add semantic rules, that is called as syntax directed translation. Syntax directed translation. Sir, what is this syntax directed translation? Syntax directed translation is used in semantic analysis for construction of annotated parse tree or for finding or detecting the errors. Sir, how it is useful? I will explain you, sir. How it is useful, the syntax directed translation. How it is useful, I will explain you. So here the question is, by adding semantic rules to the context-free grammar, we can get syntax directed translation. So the formal definition for this is, it is a formalization where each grammar production is associated with semantic rules, where each grammar production is associated with semantic rules, where each grammar production is associated with set of semantic rules. The next point is, what is semantic rule? We can get the SDT by adding the semantic rules to the context-free grammar. We can get the SDT. With this SDT, we can do many things in semantic analysis. We can find the errors. We can construct the annotated parse tree, and along with that, we can do many things. For that purpose, we need to add the semantic rules to the context-free grammar. Now, what is a semantic rule? Semantic rules are used to compute the attributes which are used to compute the attributes, which are used to compute the attributes. That is nothing but semantic rules. The semantic rules is nothing but which are used to compute the attributes, which are used to compute the attributes. Attribute is nothing but type or scope. Attribute is nothing but it, that is nothing but type or scope. It variable, scope, or details type. So that is nothing but attribute. For computing attribute, we are using semantic rules. Those rules, by suppose if we add those rules to the context-free grammar, we can call it as syntax directed translation. Syntax directed translation. For example, S derives xw, S derives small y, S derives capital S, small z. So this is context-free grammar, sir. This is context-free grammar, sir. By adding the set of rules, by adding the set of semantic rules, printf or print 1, print 2, print 3. So this is the grammar production, and that is associated with semantic rule. That is associated with semantic rule. This is the grammar production, and this is the associated semantic rule, sir. This is the associated semantic rule. This is the grammar production. This is the associated semantic rule. If we add semantic rules to the context-free grammar, then we can call that one as, totally we can call this one as syntax directed translation. Syntax directed translation. So by adding semantic rules, these are the semantic rules, sir. These are the different semantic rules. These are associated with the grammar productions. So totally we are calling that one as syntax directed translation. Syntax directed translation. If we take one more example, S derives ER, R derives star E, E derives F plus E, and F derives S ID. And here the semantic rules are print star R slash epsilon, and next print plus slash F, print id dot value. So these are the semantic rules. These are the semantic rules, and this is the context-free grammar, and this is the context-free grammar. By adding these two, we can write it as, this is the syntax directed translation. Syntax directed translation. So syntax directed translation is nothing but context-free grammar associated with semantic rules. Context-free grammar associated with semantic rules is nothing but syntax directed translation. Is nothing but syntax directed translation. Sir, what is the use of this syntax directed translation? What is the use of this syntax directed translation? So SDT is used to design semantic analysis space. SDT is used to design the semantic analysis space. Semantic analysis space can be designed. Semantic analysis space can be designed with the help of SDT. SDT is nothing but a syntax directed translation. Syntax directed translation is nothing but a context free grammar along with semantic rules. And SDT is also used to design of intermediate code generation phase. Intermediate code generation phase. Sir, the syntax directed translation is useful in semantic analysis phase, as well as it can be useful in intermediate code generation phase. In the next phase also we use the syntax directed translation. Syntax directed translation is used in semantic analysis phase as well as intermediate code generation phase also. And SDT is used for detecting the semantic errors. The semantic errors can be detected with the help of SDT, and it is also used for the construction of syntax directed translation is also used for construction of symbol table. Symbol table can be constructed with the help of syntax directed translation. Symbol table is nothing but the data structure which is used in compilers. The symbol table is nothing but the data structure which is used in compilers for storing the variable information and type information. So, and everything about some tokens. So everything can be placed in symbol table. This symbol table is connected to all the phases of the compiler, and it is also used for the implicit type conversion. It is also used for implicit type conversion. Sir, what is implicit type conversion? So in every programming language, we know about the type conversion. Converting one type of data into another type of data. Sometimes integer is converted as character, or character is converted as integer. So that is called as type conversion. This type conversion can be done in two ways. One is implicitly, another one is explicitly. Suppose if any type conversion is performed by done in implicit, so that can be done by the system. Suppose if user perform type conversion, that is called as explicit type conversion. Here the SDT is used for implicit type conversion. That means suppose system wants to convert one type of data into another type of data, that can be done with the help of SDT. So SDT is used for designing of semantic analysis phase, and it is also used to design the intermediate code generation phase, and it is useful for detecting of the semantic errors, and as well as for the construction of symbol table, and for construction of it is also used for implicit type conversion. It is also used for the type conversion, sir. For the type conversion also we use syntax directed translation. And sir, what type of errors we may get in semantic analysis? What type of errors? What are the different type of errors we may get in semantic analysis? or else we can call it as semantic errors. We can call it as semantic errors. What are the different kind of semantic errors? One is undeclared variables. Undeclared variables. Undeclared variables. It is the semantic error. Undeclared variable. Undeclared variable is the semantic error. And second one is type mismatch. Type mismatch. And third one is array index out of bound. Array index out of bound. We allocate less memory and we try to store more number of elements than the allocated size. Then we can call that as array out of bounds. And fourth one is multiple variable declaration. Multiple variable declaration in the same scope. In the same scope, if we declare multiple variables, that is also the semantic error. Another one is incompatible type in expression. Incompatible type in expression. Suppose the data are characters, we are applying addition operation. So that is incompatible type expression because we cannot add characters. But implicitly the character can be converted as integers, then we will get the answer. So by converting the character as ASCII value, we will get the answer. But directly in some incompatible type of expressions are there. String and integer we cannot add. String and integer we cannot add. So in any expression there may be a incompatible type. Another one is divisible by 0. Divisible by 0. All these are semantic errors. And all these errors can be recognized. And catch these errors with the help of SDT. We need some technique. For recognition of errors. In the previously we used finite automata. In lexical analysis, and push down automata or DPDA in syntax analysis for recognizing the strings, or else they will produce some errors. Like that, here also some semantic errors are there. So those errors can be recognized or detected with the help of syntax directed translation. So that is the technique, or that is the method, or that is the algorithm we are using for identifying or detecting the semantic errors. So finally, there are two things we need to learn from semantic analysis. One is construction of SDT. How to construct SDT. So this is the thing we need to learn. And second one is we need to learn. So second one is we need to learn getting the output or value from given SDT. Suppose if any question, if they give SDT, we need to calculate the output or the value, particular value. So that kind of questions may ask in GATE examination. And one more type of questions we may get is construction of SDT. So these are the two different kind of questions we may get in GATE examination. One is construction of SDT, another one is getting the output. What is the output is generated with the given SDT, with the given SDT. So these are the two different kind of questions we may get in GATE examination, sir. We may get in GATE examination. Suppose from the second one, if we see one example, so question may ask like this. A shift reduce parser, carries out the actions specified within braces immediately after reducing with corresponding rule of a grammar. The given SDT is S derives XX W and S derives small y and W derives SZ. Here the semantic rules are print 1, print 2, print 3. Print 1, print 2, and print 3. So SDT is given. We need to calculate some output. So what is the next continuation of the question, sir? What is the translation of X, 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 Y, Z, Z using the SDT scheme described by the above rules. Option A 23131. Option B 11233. Option C 11231. Option D 33211. So this is the question, sir. Asked with SDT. Here SDT is given. And asking the value or output. So this kind of questions, sir. So getting the output or value from the given SDT. SDT is given and he is expecting what is the output of the given SDT by accepting or in the translation of the string X, 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 Y, Y, Z, Z. Suppose if you get question like SDT is given and string is given, first you please write the parse tree for that. First you please write the parse tree for that. Suppose for accepting parse tree, so we can write it as, suppose if I start at bottom, x x x x y z z z. So this is given, sir. X x x x y z z, sir. So that is given. So with the rules are s derives x x w and s derives small y and w derives capital S Z. These are the rules, sir. Or this is the grammar. For this grammar, we need to construct the parse tree for this string. So suppose if I apply bottom-up parsing, so I can replace y with capital S. I can replace y with capital S. Then x x x x S Z Z. S Z Z. Now SZ can be replaced with W. So x x x x W Z W Z W Z. So here x x x W Z, sir. So I replaced x z with W. If you see here, x x W is there. That can be replaced with the help of yes, x x S W Z. S W. Sorry, sir. W is not there, sir. W is not there because x x W is replaced with S. So XX S and only Z, sir. So now SZ can be replaced with the W. XXW. XXW means yes. We started at bottom and we reached to the root. We started at the bottom and we reached to the root. Suppose if we start at leaves and reach to the root, that can be called as bottom up parsing. So this is the parse tree. So suppose if you want to write, you can write. So this total, this is, and S can be this and this one. S can be this and this one, and X, and from this W and Z. So X, S, Z, Z. So this is the parse tree, sir. So here a question is, what is the translation of using SDT scheme described by the above? So at the time of translating this one with SDT, we need to replace the reduce action. What is immediately given in the braces? So suppose if you reduce yes, you need to print 1. Suppose if you reduce S derives Y, you need to print 2, sir. Suppose if you reduce W derives SZ, you need to print 3, sir. In the same manner, here what we reduced, sir. Y is reduced. Y means 2, 1, 3, sir. So that means first one is what we reduced 2, sir. 2. So here what we reduced SZ means 3. What we reduced here? XXW. XXW means 1. What we reduced here? What we reduced here? SZ. SZ means 3, sir. What we reduced here? XXW. XXW means 1, sir. 1, sir. Is there any reduction here? No, sir. So reduction is not there. So here the rule is at the time of reduction, we need to print the specified value. We need to print the specified value. If we print the specified values after the reductions, what we will get, sir? 231, 231. So the option 231, 231 is the output of the SDT after the translation with the given rules and grammar. With the given rules and grammar. Here, one shift reduce parser is there. In that shift reduce parser, we are reducing the grammar or rules. We are reducing the rule. Rule is nothing but a production. We can also call the rule as production. For corresponding production, we are having some semantic rule. At the time of reduction, we need to print or we need to use that rule. So by using that rule for the translation of XXXX, Y, Z, Z, so we get the answer as 231, 231. So this is the way for finding the output. We will see some more examples, sir. Don't worry. So after completion of this concept, you will get some knowledge on this one. How to solve the problems for the given SDT, and how can we find the output for the given SDT? Like you can answer the questions, sir. After completion of the topic, you can answer the questions, sir. So suppose if any time you get the question by giving SDT for that questions or for that grammars, you need to construct the parse tree. By constructing the parse tree, you can answer the questions. Sir. For constructing the parse tree, you can answer the questions. So suppose if you see another example. Consider the grammar. With the following translation. The following translation rules. And E as the start symbol. So here the given SDT is, here he clearly mentioned, sir. He clearly mentioned. Consider the grammar. Grammar is nothing but context-free grammar. Along with the following translation rules. Translation rules means semantic rules. The rules required to translate the attributes, which is nothing but translation rules or semantic rules. So these are given, and he has also mentioned the start symbol is E, like he mentioned the start symbol is E, like, and E derives E1 hash T, and the rule is E dot value equals to E1 dot value star T dot value. And second one is slash T E dot value equals to T dot value. T dot value equals to T dot value. And next one, T derives T1 and F. T dot value equals to T1 dot value plus F dot value and F derives slash F T dot value equals to F dot value. T dot value is equals to F dot value. And F derives num. Here the rule is F dot value equals to num dot value. Here F dot value is equals to num dot value. So the question is, here the SDT is given, here the question is compute E dot value for the root of the parse tree for the expression 2 hash 3 and 5 hash 6 and 4. Here the options are option A 200, option B 160, option C 180, option D 40. This is the previously asked question, sir. This is the previously gate question. Consider the grammar with the following semantic rules. Simply we can say that SDT is given. And he is expecting output. He is expecting the value. Compute the E value or nothing but output at root. What is the output at root? For that purpose, for finding the parse tree, for the construction of the parse tree, he has given some string or some expression. For that expression, first we need to construct parse tree. For that construction, we need to construct parse tree. After construction of parse tree, we can give the annotations. After that, we can calculate the output. Suppose if we construct a parse tree, for that the given thing is 2 hash 3 ampersand 5 hash 6 ampersand 4. For this we need to construct the parse tree. The grammar rules are E derives. The grammar rules are E derives E1 hash T slash T derives T1 ampersand F hash F derives ID. ID. With these grammar rules or with this grammar, for this expression, we need to construct a parse tree. We need to construct a parse tree. If I started root, so root is user, So I need 2 hash 3. I need 2 hash 3. So for that purpose, I am taking E1 hash T. That means with E, there are 2 productions, E1 hash T as well as T. That's why here we need to choose one of these two. I need hash. For that purpose, I am using E1 hash T. E1 hash T. Sir, here E1 and E both are same. Here T and T1 both are same. These two are not two different non-terminals. But here left hand side there is E and right side also there is a E. For the separation point of view, in the question itself, they mentioned E1. E1 is not different from E. E1 is not different from E, sir. So both are same. So from this, I can expand again E1 hash T. E1 hash T. So here E1 or E can be expanded as T, and T can be expanded as F. F can be expanded as ID. F can be expanded as ID. So ID star. ID means ID value equals to 2, sir. Here it is given. ID dot value is equals to 2. ID dot value is equals to 2. It is given, sir. It is already given. So in the same manner, here T can be expanded as F. F can be expanded as ID. Again, ID dot value. After hash, the value is 3, sir. Here, this ID value is 3. This ID value is 3, sir. Here, this ID value is 3. But if I take F here, so it is completed here. But I need ampersand. So for the purpose, T can be expanded as T can be expanded as T ampersand and F. T ampersand and F. After that, T can be expanded as F. F can be expanded as ID. ID dot value is equals to 3, sir. ID dot value is equals to 3, sir. ID dot value is equals to 3. F cannot be expanded more. Only one is there. That's why ID. ID can be expanded. After ampersand, the value is 5, sir. After the value is 5, sir. ID dot value is 5, sir. ID dot value is 5 here. After that, we are having hash. After that, again, we are having 6 ampersand 4. That means T can be expanded as T ampersand F. T can be expanded as F. F can be expanded as ID. ID dot value equals to 6. ID dot value is equals to 6. And here F can be expanded as ID. ID dot value is equals to 4, sir. ID dot value is equals to 4, sir. So here the construction of parse tree is completed. Here the construction of parse tree is completed. Construction of parse tree is completed. So I am not using any type values. The construction of parse tree is completed. The construction of parse tree is completed. For this parse tree construction, we need to give the annotations. We need to give the annotations. So the annotations means by giving the type or attribute, we can get the annotations. Suppose id dot val. id dot val, what is the value here? That is 2, sir. id dot value, that is equals to 3, sir. id dot val, that is equals to, id dot value is equals to 5, sir, here. id dot value, sir, that is 6 here, sir. id dot value, sir, that is 4, sir. That is 4, sir. Now we need to calculate the value at start symbol E. The value at the start symbol E. So for that purpose, we are using the rules. We are using the rules. If num dot value, suppose f derives num, the rule is f dot value is equals to num dot value. F dot value is equals to num dot value. That means, so the f value is equals to f dot value is equals to 2, sir. So id value is same as f value. id value is same as f value. Here also f dot value is equals to 3, sir. Here also f dot value is equals to 5, sir. F dot value is equals to 6, sir. F dot value is equals to 4, sir. So if anywhere, if the production is in the format of f derives id, the rule is f dot value equals to, f dot value is equals to id dot value. Here id dot value, what is the id dot value? 2, sir. So that is the same thing copied. That is the same thing copied to the f dot value. The same thing is copied to the f dot value, sir. So that's why here f is equals to, f dot value is equals to 2, f dot value is equals to 3, f dot value is equals to 5, f dot value is equals to 6, f dot value is equals to 4. The same id value is copied to the f. The same id value is copied to the f, sir. Next, suppose if we see this, it is in the format of t derives f. It is in the format of t derives f. If we see the rule at t derives f, t derives f means the f value is copied to the t. The f value is copied to the t. Suppose if anywhere is the format of t derives f, then t dot value equals to the same of f. Here also the same. So that's why t dot value is equals to 3, sir. 3 dot value is equals to 3, sir. Here also the same, sir. T dot value is equals to 6, sir. T dot value is equals to 6, sir. So here t dot value is there. Here t dot value is there. Here t dot value is there. Now we need to compute. We need to compute this value. This value t dot value. It is in the format of t dot value derives t ampersand f. T ampersand f or t dot value f dot value. T dot value f dot value. What the rule specifies? If it is in the format of t derives t ampersand f, t dot value can be computed. T dot value can be computed by adding t dot value plus f dot value. By adding t dot value and f value, we can get the t value. Here the t value is 3, sir, and the f value is 5, sir. By adding these two, we'll get 8 here. We'll get 8 here because 3 plus 5 means 8, sir. 3 plus 5 means 8, sir. And next one is For computing this one, we need this value, E value. E value, where from this, because E value equals to T, because E derives T format. This is E derives T format. Suppose if you see here, this is E derives T, E derives T. So the T value is copied to E dot one value, that is 2 cell. That is 2 cell. That is same. That is same. Now here it is in the format of, now it is in the format of E derives E derives E hash T. For this we are now calculating. This format is E derives E hash T. For that the rule is multiply E1 value with T value. Multiply E1 value with T value. After that the result will be copied to the E value. So for that purpose, E1 value is 2 sir, and T value is 8 sir. By multiplying these two, we'll get 16. Sorry, we'll get 16. Sorry, sir. We'll get 16 here. E dot value is equals to 16. E dot value is equals to 16, sir. Now calculate here, sir. T and F. T and F. That means addition. Addition. Now the value here is 6, sir, and the value here is 4, sir. By adding these two, we'll get T dot value is equals to 10. T dot value is equals to 10. Now here also the format is E derives E hash T. So that means multiplication. By multiplying 16 and 10, the E dot value is equals to 160. The E dot value equals to 160. The E value equals to 160. So that is the question asked. So compute the E dot value for the root of the parsing tree for the expression, this one, with the given STT. The answer is 160. The answer is 160, sir. The answer is 160. So every time we need to construct parse tree for the given STT for finding the value or output. Suppose if gate question they want to give some complexity, so at that time the questions may come from 2 marks questions may come from SDT. 2 marks question may come from SDT. So because some difficulty is there here, so by practicing we can overcome that difficulty and the difficult situations. But if the gate question is a complex paper, then you may get the 2 marks question from SDT. And most of the SDT questions are SDT will be given, and they ask the output for the given SDT. And expression, they will ask the output. So if you understand this, you can answer this kind of questions. If you are unable to understand this one, so it may be difficult for you. So if you are having doubt for finding the output for the given SDT and the expression, you can ask, sir. I will explain 2 more problems or at least one problem. For this problem, if any one of you are having doubt how to construct the parse tree, how to give the values, how to compute the output, you can ask. Okay, sir. We will see one more example. After that, if you are having any doubt, You can ask, sir. I will explain. Right. Consider the following SDT. The following SDT. S derives S plus S. S derives S star S. S derives S minus S. S derives open parenthesis, closed parenthesis, yes, sorry, open parenthesis, yes, closed parenthesis, S derives ID, sir. ID. For this, the rules are S dot value equals to S1 dot value minus S2 dot value. Sir, here S1, S2 means for the separation point of view, they have given numbering. That's it. That's it. So this S value we are calculating. So for that purpose, we are using this S and this S. So every S is not same. That's why they are differentiating the S values. For that purpose, they have given some numbering S1, S2 like that is the thing only, sir. Next, S dot value equals to S1 dot val S1 dot val plus S2 dot val and S dot value equals to S1 dot val multiplication S2 dot val. Here S dot value equals to S1 dot val plus 2 and here S dot value equals to ID. So here it is very simple, sir. If the production is in this format, you have to calculate this. Suppose if the production is in this format, you have to apply this. Suppose if the production is in this format, you have to apply this. Suppose if the production is in this format, so then you need to use this one, sir. So that is the thing we have to perform. Next, the question is the value of attribute computed at root when the following expression is evaluated using SDT is. So he is not given the options, just he is giving the fill in the blanks. The expression is open parenthesis 5 star 4 minus 8 close parenthesis plus 12 sir. So this is the expression given and these are the rules. For this expression, we need to construct the parse tree. The expression is 5, sorry, open parenthesis 5 4 and minus 8 plus 12, sir. So this is the expression given. For this expression, first of all, we need to construct the parse tree. For this construction, we need to construct the parse tree. So I started at root, sir. Root is S. Here all are S productions only. I started at root. So here with the parenthesis and without the parenthesis, the difference is plus operation, sir. For that purpose, I am taking here S plus S. before plus the S is within the parenthesis. The S is within the parenthesis. For the purpose, I am taking this one as open parenthesis. Yes. Open parenthesis. Yes, sir. So I'm taking like this. I'm taking like this. So from this, S is calculated as, so two things. One is minus operation, another one is multiplication operation. Another one is multiplication operation. So before going to another parenthesis, we are having minus. That's why I'm taking this one as S minus S. S minus S. And now again open parenthesis, and now S star S. S star S. Every S is ended with the ID, sir. Every S is ended with ID. 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 So here ID dot value. Here ID dot value. ID dot value is equals to, first one is 5. ID dot value is equals to, second one is 4. ID dot value 8. ID dot value 12, sir. ID dot value 12, sir. ID dot value 12, sir. So suppose if any production is S derives S star S format, S derives S dot S format. So that tells use plus operation. Use plus operation. So here we need to use plus operation. 5 plus 4. 5 plus 4. That is 9, sir. Here S dot value is, here S dot value is 9. Here S dot value is 9, sir. Here S dot value is 9, sir. After that, after getting S dot value 9, here if you see S derives yes. Suppose if S is in this format, S dot value plus 2. Here the S dot value is 2, sir. Sorry, 9, sir. 9 plus 2. Here S dot value is equals to 11. S dot value is equals to 11. Here ID value same will be copied. That is S dot value is equals to 8. S dot value is equals to 8. That is same, sir. That is same. And now here the format is S derives S minus S. If we get minus, the format is multiplication. The format is multiplication. Suppose if we multiply 8, if we multiply, sorry, if we multiply 11 with 8, 11 with 8, that is 88. That is 88. So now if we place 88 here, after parenthesis plus 2 will be added. So S dot val, now S dot val is 88. S dot val is equals to 90, because if any production is in this format, so S dot value equals to S dot value plus 2. S dot value plus 2, sir. S dot value plus 2. In this criteria, 88 plus 2, 90, sir. 88 plus 2, 90, sir. Now here the value is 12. Here the value is 12. Here the format is S derives S plus S. If the rule is S plus S, the production is S plus S, the rule is S1 dot value minus S2 dot value. Here it is S1 dot value. Here it is S2 dot value. 90 minus 12, that is dot value equals to 78. That value equals to 78. So the output of this expression for the given SDT is 78. The output for the given expression and for the given SDT, the value is 78. The value is 78. Just we need to know how to draw the parse tree. After construction of the parse tree, we need to apply the rules. Then we can get the answer, or we can get the output cell. So this is the questions you may get using SDT for finding the output or value. Suppose if they want to give some typical question, they may ask like this. For the same question, SDT will be given. Consider the following SDT. SDT is given. S derives S plus A, S derives A derives A minus B, A derives B derives ID. The rules are S dot val equals to small a. S dot val equals to A dot val, and A dot value equals to B, small b, and A dot value equals to B dot value. B dot val equals to ID dot number or value, anything, sir. So SDT is given. Now the question is what is the missing expression? What is the missing expression at A and B? What is the missing expression at A and B if the string 8 minus 5 plus 14 minus 1 plus 14 minus 1 plus 4 minus 2 to produce output as 1170. Here in this question, he has given SDT, or we can say that partial SDT, because he doesn't mention A value as well as B value. Two values missed. We need to calculate those values. Or we need to identify those values. No need to calculate here, sir. We need to identify the missed. We need to identify the missed expressions or missed values. So expression is also given, output also given. Now here we need to identify the missed expressions of SDT. Here we need to identify the missed expressions of SDT. Suppose the options given are option A equals to S1 dot value minus A dot value, comma, B equals to A1 dot value plus B dot value. B dot value. Option B, A equals to S1 dot value plus A dot value, comma, B is equals to A1 dot value multiply with B dot value. And C, option C, yes, A is equals to S1 dot value multiply A dot value, comma, B is equals to A1 dot value plus B dot value. Option D, none of the above. So the question previously asked gate questions, and this is also previously asked gate question. The question is asked like this: SDT is given by missing some expressions, and string is given, output is also given. Now we need to check what are the missed expressions. Here also, first we need to construct the parse tree is good. After constructing parse tree, we need to substitute this one. So then we need to check which value is matching with the output. So that is the value, or those are the missed values. So first we construct parse tree for the given string. 8 minus 5 plus 14 minus 1 plus 4 minus 2. So this is the string given. The grammar is S derives S plus A, S derives A derives A minus B, and A derives small b, capital B derives ID. So this is the given grammar. For this grammar, first we are trying to construct parse tree. So I started at root. As usual, I started at root, sir. After starting the root, I am taking this one, sir. Suppose if I take here, if I take A, so that is ended with A minus B. But I need 8 minus 5 plus 14 minus 1 and 4 minus 2. For that purpose, I am taking this one, sir. S plus A. Sir. After that, I need again S plus A. So for that purpose, I am taking S plus A, sir. S plus A. This A produce A minus B. This A produce A minus B. This S is producing A, and A is producing A minus B. And this A is producing A minus B. And this A is producing A minus B, sir. So here A means again B and D. Again B, sir. So B means ID. B means ID. So suppose if we replace the values, ID dot value, initial value is 8, sir. ID dot value 5, sir. ID dot value is equals to 5, sir. ID dot value is equals to 14. ID dot value is equals to 1. ID dot value is equals to 4. ID dot value equals to 2. So these are given. After that, we need to replace. Suppose here for producing A minus B value, we don't know what is the B value. Suppose if I take the B value as A1 value plus B dot value. Suppose if I apply plus operation there. So 8 plus 5, that is 13. That is 13. A plus A. A value is here. B dot value is also A dot value is sorry, B dot value is I dot value. So that is 8. Here it is 5. So here it is 8. After applying A plus 5, the value is 13. The value is 13. Suppose if I check here, 14, 1. Here it is 14. Here it is 14. So minus means plus operation I am applying. So that means this is 15. This is 15. This is 15. Here also 4, 4, 4, 4, and this is 2. By applying plus operation, the value is here, the value is 6. Here the value is 6. And next one is S plus A. Here also the value is not given. Suppose if I use this one, S1 dot value minus A. That means if I apply minus operation, 13 minus 15, that is equals to minus 2. Minus 2 minus 6, that is minus 8. So, but the output is 1170. So by applying this, I am not getting my value. That's why I choose another one. Suppose if I choose this one. Now we will check. By multiplying these two, 8 5s are 40. By multiplying these two, 14 into 1, 14. 4 2s are 8. So here I used this one. And the same time, by applying this plus operation at S plus A, if I apply plus operation, 40 plus 14, the value is 54. 54 plus 8, the value is 62. Suppose if I apply, the value is minus 8. If I apply this 62, these two are not matching with the given output. So for that purpose, I am trying to use third one, sir. First one is plus operation and second one is multiplication operation. First one is plus operation and next one is multiplication operation. Suppose after performing plus operation, the value is 13 here. After plus operation, the value is 15 here. After plus operation, the value is 6 here. 13, 15. After multiplying, 15 multiply with 13. 3 5s are 15. 3 1s are 3, 4, 5, 1. 195. So here the answer is 195. 195, sir. So 195 multiply with 6. 195 multiply with 6. 6 5s are 30. 6 9s are 54. 54 plus 3, 57. 6 1s are 6. 6 plus 5, 11. So the output is matched by substituting these expressions. So the missed expressions are, in the place of A, S equals to S1 dot value multiply with A dot value, and in the place of B, A derives or A value equals to A1 dot value plus B dot value. By substituting these, we'll get the output, sir. So option is C, sir. Option is See, so suppose if they want to ask some difficult questions, they may ask like this. Suppose if you get this kind of questions, we need to substitute all the expressions and need to check the output. So then the matching output is the correct answer. The matching output is the correct answer, sir. So these are the questions you may get from the SDT with output. SDT with output, sir. We are having one more, that is the construction of SDT. We need to discuss the construction of SDT. From the SDT or semantic analysis or semantic analyzer, majorly you will get the questions from SDT. Why SDT? SDT is having some advantages. What are the advantages of SDT? By using SDT applications, you may get a 1 mark question, sir. You may get 1 mark question from these points. So what are the applications of the SDT? SDT applications are for designing of semantic analysis phase, for designing of intermediate code generation phase, for detecting the semantic errors, and for constructing the symbol table, and for implicit type conversion. These are the areas used SDT. These are the areas used SDT for the construction of symbol table, for detecting semantic errors, for the construction of or for the design of semantic analysis and the intermediate code generation phase. These two phases uses syntax directed translation. So what kind of errors are there, sir? These are the different type of errors in semantic errors or semantic analysis. What are those errors? Undeclared variables. So C is equals to A plus B is there. So int A comma B is given, but C is not declared. We are using. So this type of error is called as undeclared variable. Undeclared variable. Type mismatch. Type mismatch. So int A char 5 equals to A. Here I am trying to char, suppose CH. Here I am trying to CH plus A. Result equals to CH plus A. Here CH is the string type and A is the integer type. I am using some operation. So that is called as incompatible type expression as well as type mismatch. Type mismatch. Or else suppose int A equals to S string. So here it is declared as integer and I am trying to place string. So that kind of problems are called as type mismatch errors. Array index out of bounds. Int A of 5 equals to 1, 2, 3, 4, 5, 6, 7, right? So here the size of the array is 5, but I am trying to place 7 values more than the size. So that is that kind of errors are called as array index out of bounds. More values I am trying to place, but the size of memory allocated is less. The memory size allocated is less. I am trying to store more values. And next one is multiple variable declaration in the same scope. So in the functions like you will get these kind of errors. Suppose local declaration and global declaration like that. So you may get this kind of problems and incompatible. And next one is divisible by 0. Anything divisible by 0 is called as error. That kind of error is called as semantic error, because in the syntax error we could not find the divisible by 0. That is called as syntax error. So for the purpose to fulfill all these applications and to find all these errors, we need SDT. So SDT is nothing but context-free grammar plus semantic semantic rules. Context-free grammar plus semantic rules is nothing but SDT. Context-free grammar plus semantic rules is nothing but SDT. This SDT is used where each grammar production is associated with set of semantic rules. Suppose if the grammar production associated with semantic rule is called as syntax directed translation. What is semantic rule? Semantic rule is nothing but which is used, the rules used for computing the attributes, the rules which are used for the computing the attributes. That is nothing but semantic rules. That is nothing but semantic rules. From this concept or from this semantic analysis, we will get the questions on SDTs are majorly. So in the SDT, we may get the questions construction of SDT as well as the output and value for the given SDT. So these are the major two areas to get the 2 marks questions, or else you may get the 1 mark question as the theoretical question. 1 mark question as the theoretical question. The theoretical questions you may get from these two areas. One is the applications, another one is kind of semantic errors. Kind of semantic errors. Or they may give some code and ask which of the given one is semantic error like. Which of the following is the semantic error like. So this is about semantic analysis, sir. In the next class, I will explain you how to construct SDT. How to construct SDT. So, and we will do 2 or more problems with SDT, given SDT. With given SDT also, I will explain 1 or 2 problems in the next class. After that, I will explain you how to construct SDT. How to construct SDT. By learning how to construct SDT and how to find the output or value for the given SDT, you can answer 90% of the questions from the semantic analysis. 90% of the questions from the semantic analysis. Questions are from these 2 areas. You may get the questions from these 2 areas. So this is the thing, sir. In the next class, I will explain you the construction of the SDT. The construction of SDT. If you are having any doubts regarding today's class, you can ask, sir. If any one of you are having doubts regarding today's class, semantic analysis, what is the purpose of the semantic analysis? What is a parse tree? What is annotated parse tree? Parse tree, the difference between the parse tree and annotated parse tree is nothing but just a tree. But annotated parse tree means by adding attributes to the grammar symbols, by adding the type or attributes to the grammar symbols, we will get the attribute grammar. By adding, we will get the attribute grammar. So annotated parse tree means if you give the type to the parse tree or the symbols, then that parse tree is called as annotated parse tree. Then that parse tree is called as annotated parse tree. We cannot directly construct the annotated parse tree with the help of CSG. For that purpose, we are using attribute grammar. Attribute grammar is nothing but by adding attributes information or type information to the context-free grammar. That is nothing but attribute grammar. That is nothing but attribute grammar. So next one is SDT. What is the purpose of SDT? What is SDT? So what is semantic rule? So the terminology is more important, sir, for the compiler design, for constructing, for doing the problems. Without knowing the terminology and the definitions and formalization, it is very difficult for you to answer the compiler design questions from anywhere, for lexical analysis or for syntax analysis or semantic analysis. For any phase, the terminology and the formalization is very, very important. Okay, if anyone are having doubts, you can ask, sir. Otherwise, I will close the session. From today's class, regarding today's class or any previous classes, if any one of you are having doubts, you can ask. Okay, sir. Thank you.